So, Paul, it strikes me that if we keep on getting rid of all the dust, one way or another, the only way I can think to keep that dust to be in these stars we see is to keep creating new dust.
Yep, so where does dust normally come from?
Well, obviously the star was, had dust when it was formed, out of the cloud it was formed out of. And then red giant stars make a lot of dust, and supernovae make dust.
But this isn't a red giant or a supernova.
All right, so that's not going to work. Now, I know you like comets. They have some dust in them, don't they?
They sure do. Here's a picture of a comet I took in the Gemini telescope. This is what most comets look like. They're little tiny fuzzy things that move. And you can see just a little bit of a tail coming down, which is actually dust grains.
I think we probably better explain what's going on. That's actually a star, right? Where we've tracked on the comet, and so the star is being dragged along in the image.
Yes, the telescope is following the comet as it moves. This is over about 20 minutes or so, and the stars are moving across the background.
All right. So that's one little comet. What about the big comets?
It's actually a big comet, but it's a long way out. This is out to about Saturn's orbit.
Okay.
However, occasionally, most comets never get any closer than that, but occasionally comets like this one, Comet Hale-Bopp, does come closer. That's a picture I took about a day after it had been discovered, and it came closer and brighter still. Yeah. And all these times what you're seeing here is dust being blown away. What's actually happening is in the middle of the comet, these are some spacecraft images of the nuclei of two comets. There's this rather small thing, maybe about, in this case, 16 kilometers long, which is probably a dirty snowball.
And that's Halley's Comet, right?
Yes.
So one of the granddaddy comets.
And the radiation from the sun is coming in and melting it, and it's a mixture of gas and dust being blown out. And the big tail that we see is, in fact, primarily a tail of dust. Here's a little simulation showing this. So the red dot is a nucleus and the blue is the dust grains. And you can see as it comes near the sun.
Whoa. So a comet, when it comes by, really spews out dust in all directions. So this is what we need.
Yes. Now, unfortunately, our own solar system, this is not going to work too well. I mean, there aren't very many.
That's true. I waited for 15 years of my childhood to get to see a decent comet. I was expecting Comet Kohoutek to be everything, and it was terrible. And I had to wait all the way to Comet Halley, and even it wasn't very interesting.
Yeah, so it's comets are far too infrequent in our own solar system to produce anything like the dust, even in our own solar system, let alone these debris disks, which have millions of times more. However, it turns out that at least one of these other solar systems has a lot more comets, or at least comet-like things. This is a spectrum of Beta Pictoris, the star in the middle of Beta Pictoris. And you can see absorption lines due to gas. And what you can see, this is the main absorption line due to the gas, which is at rest relative to the star. But you can see this little funny shape here. What's happened is, this is a spectrum taken earlier, and that's a spectrum taken later. And the spectrum has dropped. And likewise here. And likewise over there.
Okay, so it's like there was something made out of a substance that absorbed light at these particular wavelengths, and it was there, and then it wasn't.
Yes, so it turns out that for most of the lines you see in the star, you get another line redshifted by between 10 and 100 kilometers a second. So that means the gas is moving away from us at more than Beta Pictoris is.
I see.
And it comes and goes on timescales of days. So you see this absorption appear, a couple of days, then gone again.
So you could imagine if it was a comet coming in, it will of course have a high velocity because it's coming on in a highly eccentric or even a parabolic orbit. It's moving fast, it's made out of stuff, and so we know if it were directly at the same speed as the star, it would be here. It's coming in, it has a velocity relative to the star, and we can pick it up that way.
That's right. So it looks like what's happening is the star's being hit by probably about 1,000 comets a year. Wow. Raining down, which is much more than our own sun, which is a comet this size will hit the sun maybe once every few hundred years.
So that would be a fun place to be an observer. You get to see all sorts of comets there.
Yes, but it turns out even here, where you've got hundreds of comets, 1,000 maybe a year, coming in, dumping their dust, it's still nothing like enough to produce the amount of dust you require to give us the infrared excess.
Ah, so we're still looking for another explanation.